Hello viewers, today we are going to do an interesting exercise. We will try and derive the relationship between moment of resistance of a section and area of steel required on tension side for a under reinforced and singly reinforced section. So please keep in mind the relation that we are going to derive today is applicable only and only to under reinforced and singly reinforced section. I have drawn a typical sketch of reinforced concrete beam, reinforced only on tension side with area of steel as shown. Let us call this area of steel as AST. Effective depth of this beam is D, and let us say its width is B. Now if I look at this cross section from this side, I am going to see the cross section as a line, and let us say this is the position of neutral axis at failure. So that is denoted by XU in this diagram. XU is the distance of neutral axis at failure from extreme compression fiber. As it is under reinforced section, I have not called it as XUB. Instead, I have denoted it as XU. Now we know that all the fibers above the neutral axis are going to be in compression, as we assume that the beam is subjected to sagging, and all the fibers below the neutral axis are subjected to tension, but we neglect the contribution of concrete on tension side. Therefore, we only consider area of steel effective in providing tensile resistance. Therefore, the tensile resistive force TU is shown here. As you can see, it is going away from the cross section and therefore it is pulling the cross section. Whereas the compressive force offered by the concrete above the neutral axis is shown here and denoted by Cu. As it is towards the cross section, it is pushing the cross section. We know that this Cu and Tu, they must be equal in magnitude and they are opposite in sense. Distance between them has been already derived as d minus 0.42 times XU. Trying to develop a relationship between moment of resistance of this cross section denoted by Mu and AST, that is area of steel provided on tension side of bending. To derive this relation, let us first write down Cu equal to Tu. This is required for equilibrium. Now let me write down the value of Cu. Cu is 0.36 FCK B XU and Tu is written as 0.87 FYAST. By equating Cu and Tu, we will be able to write XU as 0.87 FYAST divided by 0.36 FCKB. This works out to be equal to 2.4166 Fy upon FCK AST by B. Now, let us write down the expression for moment of resistance of a section. Moment of resistance of a section Mu can be written as Tu or Cu, but in this case, as we have to evaluate AST, we will write it as Tu into lever arm. Value of TU is 0.87 Fy AST, and lever arm, as can be seen here, is D minus 0.42 XU. D minus 0.42 XU. So lever arm is D minus 0.42 XU. Now I am going to substitute value of XU obtained in this expression. Upon substitution, the equation looks something like this. This equation can now be further simplified and written in the following form. So as you can see, this expression is quadratic expression in AST. So we can solve this for AST by invoking the result for solution of general quadratic equation. Let us say general quadratic equation is AX square plus BX plus C equal to 0. We know the solution for this equation is X is equal to minus B plus or minus square root of B square minus 4AC whole thing divided by 2 times A. We will invoke this solution for solving quadratic in AST. So now in correlation with this expression, AST is now X. Then the value of A is this one, that is minus 0.8830 Fy square upon FCKB. Value of B is 0.87 FYD, and value of C is minus MU. So by substituting these values of A, B and C in this solution, we get AST equal to minus B plus or minus B square minus 4AC upon 2A. So now as you can observe, this negative sign can be taken to the numerator. If I do so, this negative sign will vanish from here. This negative sign will become positive, and instead of positive and negative, this will become negative and positive. So therefore, AST is plus 0.87 FYD minus plus square root of 0.87 Fy square D square minus 4 times 0.8830 Fy square Mu upon FCKB by 2 times 0.8830 Fy square upon FCKB. Now as you can observe, this FCKB will venture into numerator. So both these terms I will have to multiply it by FCKB. So if I further simplify this numerator, the numerator looks something like this. Now look at this expression. Here we have 0.5 FCK upon Fy into BD minus plus this value. So I can square the denominator and divide each of this term in the under root sign by the square of the denominator. And then if I further simplify by taking 0.5 FCK upon Fy BD common from both these terms, I get AST equal to. So AST equal to, we are taking 0.5 FCK upon Fy into BD common. So therefore in bracket, the first term will become 1. This minus plus will remain as it is. And after simplification, under square root sign, I will get 1 minus 4.6 Mu upon FCK BD square. So this is the expression for area of steel to be provided on tension side for desired value of mu. We have to be very careful about the units. So let us have a look quickly. Let us quickly have a look at unit of each of the ratios involved in this term. So as we can see, the unit of B is mm and unit of D is also mm. So unit of BD square is mm square. So if this unit is mm square, on left hand side the unit of area of steel is also mm square. This indicates that this term should be unitless. So let us check if this term is unitless or not. So unit of FCK is MPa, unit of Fy is MPa, therefore this ratio is unitless. Then unit of Mu is Newton mm, unit of Mu is Newton mm, unit of FCK is Newton per mm square, unit of B is mm, D is D is also mm, therefore unit of this quantity is Newton per mm square into mm cube, so that is Newton mm. So unit of denominator is Newton mm, unit of numerator is Newton mm, it cancels out and therefore this ratio also is unitless. So this entire factor, as we can see, is unitless and therefore this equation is dimensionally consistent. We have to be very careful while substituting values of FCK, Fy, Mu, B and D. They should be in consistent system of units. So if I choose to substitute FCK in MPa, that means Newton per mm square, I should substitute Mu in Newton mm and B and D in mm. Now let us look at how AST depends on Mu. Now let us look at this dependence of AST and Mu more closely. Before we do that, we have to understand that this relationship is valid only and only if the section is under reinforced and singly reinforced and rectangular. So with this understanding, we are going to use this relationship between AST and Mu. And now let us quickly consider an example. Let us say we have a beam of effective cross section 230 mm by 500 mm. We are using M20 and Fe415 grades of concrete and steel, and we have to resist moment equal to 40 kilonewton meter. This is the design moment. So what should be the value of AST that I must be providing? To check this, first I will have to confirm that the section is under reinforced, because then and then only I can use this formula. So therefore first let us calculate moment of resistance of balanced section with this effective dimensions. It is going to be RUB into BD square, that is 230 into 500 square, and RUB for M20 and Fe415 we know it is 2.76. So this value works out to be 158.7 kilonewton meter. As Mu is less than MURB, we are dead sure that this cross section is going to be under reinforced section, and therefore now we can use this formula to compute value of tension steel required. So in this we clearly understand FCK equal to 20, Fy equal to 415. Mind you, these values are substituted in Newton per mm square. Therefore, Mu needs to be substituted in Newton mm. So, Mu will be equal to 40 into 10 power 6 Newton mm, because 40 is the value in kilonewton meter. So, we have converted it into Newton mm. FCK is 20. B is 230. And D square is 500 square. B is 230 and D is 500. So after substituting all these values in this expression, we get AST equal to 231.34 mm square. Now let us consider that design moment Mu is 80 kilonewton meter. Since this is less than Mu or B, we are considering a under reinforced section, and therefore to compute steel for this Mu, we are going to use the same formula, except all values will be same, except this value will be 80 into 10 power 6. So if we calculate the amount of tension steel that requires to be provided to resist the moment of 80 kilonewton meter, it turns out to be 486 mm square. As you can see, the moment to be resisted is doubled here, but we have to increase still slightly greater than double of 231.34. So we understand that the relationship between Mu and AST is not strictly linear. So let us summarize. If the section is rectangular, singly reinforced and under reinforced, then the relationship between AST and Mu is given by AST equal to 0.5 FCK upon Fy into bracket 1 minus square root of 1 minus 4.6 Mu upon FCK BD square into B into D. We have to understand that we should substitute FCK, Fy and Mu in consistent system of units. So if we substitute FCK in MPa, Fy also to be substituted in MPa, B and D to be substituted in mm, and Mu to be substituted in Newton mm. You may be wondering, why did I choose only minus sign here? Because in the root we had minus plus sign. But if we consider this sign to be plus, then we can conclusively prove that the steel that turns out or steel that is calculated will make the section over reinforced section, and our very assumption that the section is under reinforced will be violated, and therefore the only possible sign here is negative sign. The next question that may bother you is this: what if this 1 minus 4.6 mu upon FCK BD square turns out to be negative? Then square root of negative number will be imaginary, and in that case we will not get any real value of AST. But it can be conclusively proved that 4.6 mu upon FCK BD square, if we subtract it from 1, this number will never be negative. So there are two observations that I recorded. Observation number 1, we omit plus sign here because if we consider that plus sign, the section becomes over reinforced. And second, this term under the root sign is never going to be negative. We will prove both these points by taking an extra YouTube live session. So let us stop for today. Thank you.